Hi, welcome to this short video on finding the mean absolute deviation. And so we're going to look at how do you calculate the mean absolute deviation and how do you use it to compare data sets. The baby's really mad. Why do you think she's so mad? Let me tell you why. Because to find the mean absolute deviation, we are going to have to first, one, we're going to have to calculate the mean. Two, we're going to have to subtract each number from the mean. Three, we're going to have to find the average of those distances because what the mean absolute deviation is on average, how far are the data points from the mean? The mean absolute deviation helps us to see how consistent the data is, how clustered together it is. So it's three easy steps, but each of those steps can be time consuming. So here we go. Let's give it a shot. Let's do it. These babies are awesome. All right, so here are some shoe sizes from the Shelbyville Elementary School sixth grade basketball team, and they're listed here. So, what we're going to do is we are going to look to see how consistent is this data and find the mean absolute deviation. So, the first thing we're going to do is find the mean. So, what I'd like you to do is you're going to find the mean on your own. You can pause the video now. Okay, welcome back. So, to find the mean, I'm going to add up these numbers and then divide by 5, and I get 9. So I get that the mean is 9. So these are the data values again. This is the same list we had earlier. Now what I'm going to do is step 2, I'm going to subtract each number from the mean. So I'm going to do 9 minus 5. And then 9, the mean, minus 1. And minus 8 is 1. And then 9 is the mean, minus 9 is 0. Because that number is the mean. It's actually the median too. Now I'm going to do 11 minus 9. Why? Because the mean absolute deviation. So because it's the absolute deviation, our answer should always be positive. So I'm going to subtract this way. When the data value is bigger than the mean, I put the data value first. So 12 minus 9 is 3. There. There we go. So here's all the distances we found, all the numbers that how far they were from the mean of 9. Now what we're going to do is to find the mean absolute deviation, we're going to actually find the average of these differences. So now we're going to find the average again by adding them up, dividing by 5, and we get 2. So the mean absolute deviation is 2. And what that means is, on average, the shoe sizes in this data set, on average, are about 2 sizes away from the average. So it's saying that our data is going to be clustered around 2 sizes out from the mean. Okay, so that's what that is. And that's telling us it's kind of consistent. It's only two shoe sizes off more or less. So it's around 2 on either side of the mean. Now, we're going to compare that to a professional basketball team. And what you can notice about these shoe sizes already in this professional basketball team is that they're much larger, right, than the kid sizes. That makes sense. And so what you're going to do is, again, you're going to find the mean. So I'll pause and do that now. Okay, so I found the mean, sorry, and that's 15.8. So now what I'm going to do is I'm going to subtract all of these numbers from the mean. So 15.8 minus 12.5 is 3.3. And then 15.8 minus 14.5 and subtract each one and see what differences you get. So pause and do that now. So here's all the differences we got when we subtracted the mean and the data values. And here's the differences. So what we're going to do again is now that we found the differences is we are going to add them and divide by the number of numbers. So I'm going to find the average. So I added them up and I get this number divided by 5 because there's 5 of them. And I get a MAD of 2.16. Okay. So now let's compare the two data sets. So you have the Shelbyville ones, which the average is 9, which is much smaller than the average of the Trailblazers. But if you look at their MADs, they're very similar. So these data sets are very comparable in consistency. So their consistency is the same, even though they have very different means. There it is, mean absolute deviation. Thanks.